Well, hello everyone, and thank you for coming. So my name is Brian Cross. I am a senior solutions engineer with GitHub, and today we're going to show you the basics of automating deployments of code from GitHub to Lambda through 3 different pipelines. So we'll show you how to do it using Jenkins, we'll show you how to do it using AWS Code Pipeline, and we'll show you how to do it using AWS CodeStar. So I want to get a few things out of the way before we get started. Has everybody heard of GitHub in the room? Everybody? Some of us use GitHub? Sweet. How many of us use GitHub Enterprise on-prem at work? Oh, that's great. Okay, that's good to know. So while we agree that the talk is going well, I thought I'd take a quick selfie to memorialize this. So everybody smile and wave. All right, thanks, I appreciate that. Okay, so if things go downhill, at least I'll always have that. Okay, so let's get started. So we are, as I said, going to talk about 3 ways to deploy a single Lambda microservice from GitHub to AWS. So we'll start with GitHub and Jenkins. And the reason we're going to start here is because this will give us an opportunity to review the entire process from beginning to end. So we'll set up a development environment, we'll configure our AWS toolset, we'll configure Jenkins, we'll do all the things that you need to do so that if you pay attention from beginning to end, and I got it right, we'll see which one of those holds true, you'll be able to do this when you walk out of this room. So after that, we're going to adapt that code, mostly the configuration parts of the code, and we're going to do the same thing again, but we're going to use AWS's native code pipeline toolset in order to do that. And then lastly, we're going to do all of that again using the new CodeStar platform. So has anybody here used CodeStar or heard of CodeStar from Amazon? All right, so it's pretty cool. If you're just getting started with this sort of thing, it's a great way to get introduced to CI and deployment on Amazon. Okay, continuous integration. Is there anyone in the room that doesn't know what I mean when I talk about continuous integration? Definitely pitch this a little low for this room, it looks like. Okay, so for just a quick review for the folks online, continuous integration is the idea that every time we push code to GitHub or into our repository, we are testing it to ensure its integrity. We're doing regression tests, we're doing unit tests, we're doing everything we can to ensure that that code is complete and as free of defects as we can make it. And obviously we want to automate this so that we remove the human factor because sometimes humans don't do their testing. How does it work? So every time developers push to GitHub, GitHub can be configured via a tool called a webhook to emit a payload to a REST API endpoint. And this payload contains all the information that whatever is on the other side of that endpoint needs to pull that code from GitHub and do stuff. So what we're going to look at here in a bit with Jenkins, we're going to build that code, we are going to test that code, and we are going to deploy that code to Lambda. And if there's anything wrong at any one of those stages, Jenkins is going to return a fail response. And it's also not going to proceed. Now, if all of that stuff works, it's going to return an OK response, which is great. Feedback is awesome. What do we do with this feedback? So if everything works, the code will be deployed to Lambda. The reason this is relevant for us in GitHub is that we can leverage this feedback process to further protect our code. So there is a feature inside of GitHub called protected branches, and it's exactly what it sounds like. It allows you to impose layered protection on your code to prevent various bad things from happening to it. So in our case, if I protect my branch, and this could be my master branch, if I'm in a SaaS scenario and I'm deploying a Lambda function, this Lambda function may be going directly into production several times a day, I want to make sure that it's passed its integration test before that actually happens. I can require that status checks, in other words, these continuous integration tests that Jenkins performs, return successfully before a pull request can be merged. And everybody's using pull requests, right? Nobody's merging directly to master. We're all using pull requests. Further, I can select from any number of these tests. We're only going to set up a single test, but it may make sense for you to separate out your testing suites into unit testing, deployment testing, whatever makes sense for your particular scenario. You can select any or all of these, the failure of which will prevent a pull request from merging. And lastly, this is a really cool feature. You can require branches to be what we call up-to-date. So what we're going to do in this instance is we're going to take the code from the base branch and the branch that's going to be merged, create a sort of a temporary commit where all that code is merged, and then send that off to be tested. So this is a great way to eliminate merge surprises before you deploy to production. So again, GitHub protected branches. If you're not using protected branches, you definitely should consider doing so. There's a lot of information in our documentation, and we have a couple of webinars that describe how this functionality can really help you to protect your code and prevent bad things from happening. All right, so what would happen if Jenkins returns a fail code? When I submit, and when I push code to GitHub, I'm going to see this response while those checks are actually running. And some of the checks can take a while. If those checks fail, I'm going to see this, which means a check has failed. And most importantly, the merge pull request button will be disabled in most cases. Administrators can, if you allow them, overrule this and merge anyway, but they can't say that they weren't warned if they choose to do that. And lastly, if all the checks do pass, which of course they eventually will, then you can merge the pull request as normal if all of the other configuration parameters that you may have specified have been met. All right. So in order to do this, obviously you have to understand how to use, install and use the Amazon Web Services command line interface, the CLI. Also, you should probably have some familiarity with IAM users, groups, and roles, as well as Lambda functions and S3 buckets, and some awareness of nodes and sets of platform using Bash, NPM, and Grunt. Just for the record, when I started on this presentation, I did not, but now I do. So again, if you are following along and you want to actually do this, we're going to use Node 6.10. At the time that I created this presentation, that was the latest supported Node version in Lambda. We're using a plugin for the function called ImageMagick, which isn't necessarily very relevant to the deployment that we're talking about, but it will help you to understand the code if you ever go browse a repository. And of course, the Amazon AWS CLI. All right, so the first thing we're going to do as we start down this path is create our IAM user and group. And the reason we're doing this is we don't want to use our root user and our root authority to do anything inside of AWS. So we head to IAM, we click on Add User, and we specify a username. So I like to try to use a naming convention such that when I see a long list of usernames or group names, I can understand which one usually I just created because I often forget, or where it falls within all of the different usernames, groups, and roles that I may be creating. So in this case, we're going to choose Management Console Access, and I feel like I missed one there. We're going to specify a custom password so that we can use it again and store that password, obviously, someplace safe. The next thing we're going to do is not require that password to be reset by the user the next time they log in, because we don't intend to log in interactively with this user. It's strictly going to be used for the build process. All right. So the next thing we're going to do is set permissions, and we're going to do this by creating a group. So we're going to click Create Group. We're going to give it a name. Again, that describes where it belongs in our hierarchy of development tools. And we're going to give it administrator access. So throughout this presentation, we are going to more or less finesse security by providing administrator access and using trust relationships rather than providing long policy documents that describe what you would have to do in your specific scenario. And the reason for that is that they're really only relevant in this particular scenario. Everybody's are going to be different. The way that I found it easiest to learn how to do this efficiently was to get the pipelines working, understand how the tools work together, and then come back and overlay security on top of that in the context of something that I was actually trying to do in a real environment. All right, so we've provided administrator access, we've created our group, and we're going to go ahead and apply our user to that group and create the user. And there it is. Great. So the next thing we need to do, obviously, is get a hold of the security credentials that we're going to need later on to authorize these various tools to do things on our behalf. So I'm going to click on that user again, click on the Credentials tab, and I'm going to copy both my access key ID. I'm going to click the Show and copy the secret key as well, and store those someplace safe like a random text file on my desktop. And actually, don't ever do that. Use a password manager or something that's going to be a little more secure, and here's why. This is a simulated bill that happens when you share your access keys. And for God's sake, don't upload them to GitHub. This is a terrible, terrible thing to do, as my friend, not me, found out. Okay, so the next thing we're gonna do is create a role. So what's a role? A group is a collection of users that you can also use to manage permissions. A role is a collection of policies which describe permissions or define permissions. But roles are different in that various services can assume those roles to do things on your behalf. So we're gonna create an administrative or an admin role, and then we're gonna leverage that throughout the rest of this process to provide access to the various tools that are gonna be doing things for us. So we're gonna go back into IAM, we're gonna select roles, we're gonna create a role. It asks you to select a trusted service. We'll be adding to this later, but for now we'll just select Lambda. We're gonna provide full access to Lambda, as well as full access to Amazon S3 and CloudWatch. And these will all be relevant later as we move through this process, but it's more efficient, in my opinion, to do this in the beginning if you know what you need. All right, so we've got our role. We're gonna review it. We see that we've got our full access to the 3 services, our trust relationship. Go ahead and create the role. Great. So the next thing that we're gonna do, I guess I should mention what this application does. So it's a simple application. There's examples of this all over the web. The idea is it's an image resizer. So we've got a little microservice, which like a good microservice does one and one thing only and does it very well. It's gonna respond to an event in an S3 bucket. Somebody drops an image, an event will be fired. The microservice picks the image up and resizes it according to parameters that are hard-coded, spits it out to another bucket, the essence of simplicity. But first, we have to create that infrastructure. So we're gonna create the bucket, we're gonna give it a name, and then we're gonna repeat that process using whatever name we just chose with -resized as the suffix. All right, so we've got our buckets. Now we're gonna give it something to work on later on when we actually test this code. So we're gonna click on our source bucket, GitHub Lambda demo pics. We're gonna upload a file that I just happen to have lying around and put it into our source bucket. And this file, by the way, is a giant bunch of octocats. The point is that it's much larger than 100 by 100 pixels, which is what we've configured our resize microservice to emit on the other end. Okay, so now it's time to actually create a Lambda function. So back to the console, back to Lambda, we're gonna choose create function. And this UI seems to change about once a week, which is great because Amazon is obviously making improvements constantly, so my apologies if this is a week or 2 out of date. They provide you with a pretty good catalog of templates if you wanna start off using one of their templates. But in this case, because what we're doing is so incredibly simple, we're simply gonna author from scratch. So we're gonna give it a name that's descriptive. We're going to choose an existing role under which this function will operate, which is the admin role that we just created, and then we're gonna create the function. And that's all there is to it. So right off the bat, Amazon's gonna create a Lambda function that will run without any intervention from our part. So we can see that the code is actually coming from that little editor down there. That's what edit code inline means. We're using the Node.js 6.10 runtime, which was the most recent Node runtime that was supported, and we're letting Lambda know that the code it needs to call is the handler export. So in this case, exports.handler. We're gonna, again, make sure that our GitHub Lambda admin role is the one that's actually executing this function. Tweak the memory up to about a gigabyte, just in case somebody uploads a large image. And during development, a longer timeout makes more sense. You don't want things to be timing out while you're trying to debug, right? So go ahead and set the timeout to the maximum, which is 300 seconds. Okay, so now, before we actually save and move on to the next step, we'll just do a simple test to make sure that all this plumbing is correct. So we'll click on Save and Test, which will save our function and take us to the test utility. And this is really cool. We'll see this later on, but they provide you with a large number of templates that you can use to emit events to fire your function. But in this case, we're just going to send it a few parameters. We're going to give it a name. We're going to create this particular test configuration. We're going to click Test. And of course, it all magically works because it was created by Amazon. We actually haven't done a thing. So cool. So we're done with our Lambda function. We're ready to move on to the next phase of the operation, which is linking this Lambda function to our source S3 bucket. And the way we do that, again, is we click on the Triggers tab and then click Add Trigger. This little UI will come up, which took me a while to figure out. But if you put your mouse into that little dotted line box, this helpful list of services will appear. Scroll down to the service you want, which in our case is S3. specify the event you want, which in this case is anytime anybody creates anything in this bucket, let our Lambda function know, and submit, and you've got your event. So now we have a fully configured Lambda function that's going to be triggered when anybody drops something into our source bucket. Fabulous. Okay, so the next step is we're going to move back to our development machine. We're going to configure our command line interface. There are tools out there that require you to include your secret key and your access key in one of their configuration files, and this frankly is how stuff gets uploaded to GitHub and other places where it shouldn't be. That's why we're using Grunt. Grunt integrates with the AWS CLI very nicely, and the AWS CLI only requires you to configure it where you actually use it. So it asks you 4 questions, provide 4 answers, including the region that you're going to use wherever you might be, as well as your security credentials, and that's all there is to it. You're good to go. And if you're wondering, it stores these in a hidden directory in your home directory called .aws in a file called credentials. So it's very easy to find, it's very easy to back up, and also very easy to delete if you need to start over for whatever reason. All right, so here's the code that we're going to start off with that's actually in GitHub. And if anybody's interested later on, this is a public repository. If it's not, let me know. I intended for it to be public. Go ahead and take a look at it anytime if you want. But we're going to clone this in the way that we all know and love. We're going to clone it into our development environment. We're going to switch to that directory, run npm install, because it's a node project, and now we're good to go. We're ready to start developing. So let's take a look at package.json. The 3 things that really matter from the AWS deployment point of view are that we have Grunt, that we have the Grunt AWS Lambda plugin, and that we have the AWS SDK in our dependencies. The rest of the stuff obviously is going to vary depending on what your function is doing, but those 3 are necessary for this particular deployment strategy to work. So here's our new index.js. We still have the export.handler function, which takes the same arguments. Doesn't really matter what's going on in there. It's basically using that ImageMagick library to resize an image. But part that is sort of interesting are these parameters up here. We can change these parameters very easily, run through the deployment pipeline again, take a look at the output, and tell right away if not only is our code working, but is our deployment pipeline working, and is the code that's being deployed actually the code that we want to see. Okay, so the next thing that we need, if we want to unit test this from our desktop, we need an S3 event that we can feed to our Lambda function to see what happens. So again, we're going to return to the Lambda interface in the AWS console. We're going to go to configure test events, but this time we're actually going to select the S3 put event, and it's going to generate all of this lovely JSON, which is in fact the payload that our Lambda function is going to get every time somebody drops something into this particular bucket, which is great because that means we don't have to type all that. So we'll just go ahead and copy it. We're going to create a file inside of our project called event.json. It has to be that name. We're going to save that file, and now we're ready to go to test. Before you do, though, just make sure of a couple of things, that the source bucket name is correct, whatever you configured. Make sure that the ARN, or the Amazon resource name for that particular bucket, is correct, and then just double check that the file name is correct. They usually are, but you never know. All right, so the next thing we're going to do is we're going to use Grunt and the lambda_invoke task, which will use that event.json file, feed it to our function, and then we'll see what happens. So it'll generate all of this output, and what we're looking for really at the end is this. It worked. And then if we want to, we can actually go out to our destination bucket. We can look inside. The first good sign, there's a file in there with the right name. And the second good sign, of course, is that it's very small. So our function has worked, our test has worked, we're making progress. Okay, so the next thing that we're going to do is we're going to use grunt lambda_package to take all of our code and compress it into a zip file, put it into a specific location, and prepare it for deployment to Lambda. And the way that we do that is simply to execute grunt lambda_package. And the thing to bear in mind is where, by default, this code goes. It goes into a directory in your source tree called dist with a name, which is basically your project name _latest.zip. We're going to need to know this later when we configure Jenkins. Okay, so we've tested, we've packaged, we're ready to actually deploy from the command line. So let's go ahead and do that. One thing that we need to make sure of inside of our grunt file is that we have the ARN for our function correctly specified. And then, of course, the deploy function that I'm using in this case just concatenates together the existing package and deploy grunt tasks. So let's go ahead and run that. It's going to do its thing. It's going to package. It's going to deploy. If you're fortunate, everything is going to work. You're not going to get any errors. We haven't made any changes to configuration. So let's go and see. And an easy way to tell is, look, the code has been updated in the last 30 seconds, so things look good. If you want to, you can go ahead and run a test. You can't actually look at the code because now, instead of being edited inline in that little editor, it is sourced from a zip file somewhere off in S3, and you can't actually edit the code anymore in the Lambda editor. Okay, so if you want to, you can change those default dimensions that I mentioned before to something else and retest. It's just a good way to go. Okay, so we've built a function. We've created our AWS infrastructure. We have tested it on our desktop. We've done our unit testing. We verified that everything works the way we think it should with our deployment tool, which is Grunt. So now it's time to set up Jenkins to do all of this for us automatically. All right, so Jenkins. Folks familiar with Jenkins out there? So a lot of people complain about Jenkins. I like it when they do that. There's two kinds of continuous integration tools, the ones everyone complains about and the ones no one uses. So Jenkins is what it is, but it's out there, and it more or less works. So the first thing we want to do when we come in is we're going to manage Jenkins. So we'll click on the Manage Jenkins menu item, and then we're going to click on the Configure System item, which is at the very top. I'm sorry, the Manage Plugins item in the middle there. Use the filter at the top on the Available tab to find the Node.js plugin and select it. And if you want to, you can install that right away. Hopefully you'll get a success. And then repeat the process for the AWS Lambda plugin. So at the end of the day, you're going to have 2 plugins installed successfully, and we're ready to go. So the next thing we need to do is actually configure the Node.js plugin. So in this case, we are going to click Global Tool Configuration. We're going to scroll down to the Node.js section, give it a name, in this case 6.10, define which runtime we want to use, which again is 6.10, whether or not you want to install any packages globally. So I installed Grunt globally. You don't have to do that, but any packages you think might be useful on a global basis, you can specify there. And then let Jenkins know how often or how frequently it should reach back out to refresh those packages. Okay, so now our Jenkins server is configured and it's ready to go. The next thing to do is to tell it what to do with our code. So we're going to create a build project. And we do that again on the home screen by clicking on New Item. We specify a name. Again, if it's descriptive of what you're doing, that's helpful. And select the Freestyle project. This is the simplest and the most flexible way to get Jenkins to do stuff for you. Go ahead and click OK and begin configuring. So we are doing a GitHub project. So the first thing we're going to do is enter the URL to our repository. And don't forget the .git. It's very frustrating because it won't work if you forget the .git. The next thing that we're going to do is provide credentials. You don't have to do this if you're using github.com and you're using a public repository. Any other instance, if you're using GitHub Enterprise or a private repository on github.com, you're going to need to supply credentials. So I go ahead and just do it anyway, sort of out of habit. All right, in the next section under build triggers, we want to select the GitHub hook trigger for Git SCM polling, which is a complicated way of saying let GitHub let Jenkins know when something has changed. And the reason for this is the other choice, which is to poll GitHub, is a great way eventually, if there's more than a few people working in your system, to eventually DDoS your entire GitHub installation if you're on Enterprise, or get yourself rate limited if you're on github.com, because every single one of these jobs will continually be pinging your repository. Did you change? Did you change? Did you change? And that's just a bad practice all the way around. So live an event-driven life, and that certainly applies to Jenkins. Okay, so moving on, the next section, what do we want this thing to do when we build? And you can add any number of build steps. The first thing we're going to add is just a simple shell, execute shell. We're going to give it some commands. I always like on Jenkins, because I may or may not manage this environment, I include some debugging information. What version of Node is running, what version of NPM is running, what version of the AWS CLI is running. So in my output, I'll always see those. You may want to include also some commands to get more context around AWS, like the IAM get user command is a useful one. Next, we're going to run npm install just to make sure that our environment is up to date. And then again, the grunt lambda package task from our grunt file. We're not gonna run deploy because we're gonna use the AWS Lambda plugin to do that in a later step. Okay, and then if we have configured webhooks, we can set the status of the build to pending so that GitHub knows what's happening. And then the very last thing we're gonna do is set an AWS Lambda deployment. So it wants all of these parameters. You have to provide them, including your AWS login credentials. So you have to make a decision at this point. Do I trust Jenkins? And more importantly, do I trust whoever it is in my organization that's running Jenkins? Because without them, obviously, it won't work. Otherwise, you're specifying the ARN for your role that you created. And down there under artifact location is why it's important to know where Grunt Lambda package actually puts those artifacts. As a final step, if you want to test, you can select AWS Lambda invocation, which will actually test fire your function. You provide most of the same parameters, including your security credentials, that S3 payload that we copied from the Lambda test environment, and you're good to go. That'll be the last thing that's run. So lastly, again, if we want feedback to return to GitHub after all of this, we use the set GitHub commit status and provide basically the defaults, and that will drive that pull request behavior that we looked at earlier. All right, so we're good to go. Our project is good. Click on Build Now. You'll see the barber pole. It'll take it some amount of time, depending on the strength of your machine and the number of jobs that are running. But eventually, and usually on the first time, you'll see success, which is indicated by that little blue ball. If you click on the build, you can see your output, again, which tells you everything that happened, which is nice when things go well, but is very useful when things go wrong. So common things to go wrong are misspellings in your configuration files or permissions problems with trying to do the deployment to Amazon. You've either got your credentials wrong or you've specified a role that doesn't have adequate permissions to do whatever you're asking it to do, and you'll see useful feedback here to help you debug those problems. And then we head over to Lambda, and we see that Jenkins indeed did exactly what we asked it to do, and that our code was freshly updated. We can execute the test again if you want to do that, just to be sure. All right, so lastly, let's talk about how we set up this feedback loop with GitHub. So we're back in our repository. We're going to click on Integrations and Services. And then from the menu, from the Add Service menu, we're going to use the filter to filter it down to Jenkins and select Jenkins with the GitHub plugin. And then all we have to do at this point is enter the webhook URL. And it takes this form. So wherever your Jenkins is, GitHub webhook, do remember the trailing slash. It's very important. All right, so we've got our service integration set up and our webhook set up. Click on Test Service. It'll send a test payload. And if you see the little green arrow, then you're in good shape. Jenkins is set up to do what you want it to do. All right, that's it. That's all you have to do to use Jenkins. And again, this will work from GitHub Enterprise if you're in an on-prem environment, and it will also work from github.com. So moving forward, we could talk about how we could use different branch filters to take different actions depending on where you're actually pushing. We talked a little bit about pull requests and protected branches. There's a lot more territory to cover there, both in terms of driving continuous integration and other automation, as well as securing your code, code review, whether you want to be open source, and of course, ultimately collaborating with your community, however you choose to define that. All right, so let's move on to the next step. We're going to do basically the same thing, but this time we're going to use AWS Code Pipeline. So Code Pipeline is basically a configurable continuous integration workflow engine that allows you to link together tasks to do useful things with your code. It integrates a number of AWS services. In fact, nearly all of them are available through Code Pipeline. It's very flexible, and it allows you to both build, test, and deploy Lambda functions and other services from a single pane of glass. So in our case, our first stage is going to be source. We're going to retrieve the code, in our case, from GitHub. Then we're going to build. We're going to build the code the same way that we did before, but using a different tool set. We're going to be using code build. And then we're going to stage that code by creating an Amazon change set, and then we're going to deploy that change set by executing it. All right, so the tools that are available to you here are pretty varied. You've got code commit. You can use S3, or of course GitHub as your repository. You've got 4 different choices for building, including Jenkins that we just saw, as well as AWS Code Build, which we'll be using. And your deployment options are pretty wide open as well. You can use code deploy if you're going to EC2, OpsWorks stacks, or in our case, we're going to be using CloudFormation. So there's a few things you need to do if you want to move on directly from where we just were. AWS change sets don't like it when things that they think they're managed already exist. So delete all your AWS artifacts that you just created if you want to use the same names. Delete or disable your webhooks so that you don't have Jenkins under the covers interfering with us. Create another S3 bucket called GitHub Lambda build. That's where we're going to put our artifacts in this case. And then add the CloudFormation and code pipeline trust relationships to the GitHub Lambda admin role. So a little bit about debugging code pipeline. This was my experience in a way. It's not always permissions, but in my experience, it's always permissions. So when things go wrong, look at your trust relationships, look at the permissions that you've granted, and if all else goes wrong, back things out, use administrator access, make sure that your pipeline itself works, and then remove administrator access and start layering in the permissions that you think you need until things work the way that you think they should. So how do we add trust relationships? We go back into our role in IAM. We click the Edit Trust Relationship button. There's already one there for Lambda, so we'll just copy and paste that twice, changing the service each time to Code Pipeline and CloudFormation. All right, so there's two new build files. We're no longer going to be using Grunt. We're using code build to build our function in this case, and that relies on two files, the first of which is called buildspec.yaml. You can use JSON, but YAML's cool because you can comment stuff. And the guts of this really are in the middle, the install phase. There's actually 6 phases that are supported by code build, but in our case, we're just going to use one. So we're going to run npm install again to make sure that our environment is up to date. And then we're going to run the CloudFormation package command. We're going to be using a template file, which we'll look at in a bit, called template.yaml. We're going to put the code in that bucket that we just created, GitHub demo build. And we're going to send all of this output to a new template called newsamtemplate.yaml. And that's really all there is to it, as a zip. So the second file is where the fun really starts. This is template.yaml, which is part of the serverless framework that is at Amazon released relatively recently. And there's a bunch of different parts. So the first part here, we're defining resources. And we have to define these resources in a specific order because we're going to modify them later on in the process. So the first thing we're going to do is create our image bucket and a policy that defines access to that bucket. The second thing that we're going to do is basically the same thing, but for our target bucket, our resized bucket in this case. And then the last thing we're going to do is define our function. So the important parts of this are the configuration elements that define our runtime, our memory, our timeout, the name of our function, as well as the ARN or the ARN for the role that's going to actually execute this function. That's incorrect. That should be our admin role that we created earlier. So underneath that, we have the permissions for our function. And then the last thing we're going to do is we're actually going to add the event. And this is why this has to come at the end, because if you put this anywhere else, it doesn't work because the bucket itself that we're trying to modify doesn't exist. So the order in this file actually has significance. But in this case, we're going to attach the object created event to that bucket so that everything works the way that it did when we first started. All right, so we're going to hit code pipeline inside of the AWS console, and we're going to start by giving it a name. And again, my naming conventions make it stand out in the list. The first thing we do is configure source. We select GitHub from the dropdown of potential options, and then we have to connect to GitHub. And the way that you do this is hit that button. If you aren't already logged in, it will ask you to log in. And then it'll helpfully tell you what permissions you're granting. So again, make the decision consciously that you trust Amazon to be able to do pretty much anything it wants with your repositories. And this is an either-or decision. If you don't feel comfortable with this, you can't really use this approach. But if you do, hit the green button, and on we go. And the last thing we do at this step is deselect the default option, which is to run whenever changes in the source are detected. And what this means is that now Amazon will be pulling your repositories as well. So deselect that. Okay, the next step is the build step. We're going to use code build, so we select that from the provider dropdown, and we're going to create a new build project. When you get a couple of these built, you can, in fact, select an existing build project at this point and save yourself this step. Give it a name, fill out the parameters. In our case, we're going to use a Linux operating system running Node. It doesn't have a 6.10 option, so we use the next best thing, which is 7.0. And we are instructing it to use the buildspec.yaml that's in the source code root directory. You also have the option at this point of basically creating your own buildspec.yaml by entering commands in a dialog box. it needs a role that it's going to assume to actually perform these functions. So create a new role and give it, again, a descriptive name. And then move on to the next step. We've created a build project. This project lives in AWS Code Build. You can go look at it and edit it there if you want to. Click Next Step. The next step is deploy. We're going to use CloudFormation. And what we're going to do is create or replace a change set. That's the action mode that we select. Give your stack name, which the change set is going to create, and the change set itself distinctive names. And then remember that the template is new SAM template that we defined in our buildspec.yaml a few slides ago. We want to use capability underscore IAM because we're not defining anything with respect to roles or the other things that we require capability named IAM. And then what role is going to handle all of this? It's going to be the admin role that we created. Pipeline also requires a service role to sort of manage all of these things at one time. Again, because of our administrative permissions, we can use our admin role. Review your steps and create the pipeline. And right off the bat, it's going to run, and right off the bat, it's going to fail. And the reason for that is that the service role that we created doesn't have the authority to create anything. So if you want to create your S3 resources, your S3 buckets, then you need to add those permissions. The easiest way at this point is to add administrator privileges, and then you can go back and use the IAM policy simulator, if you like, to add the actual specific permissions that that role needs. Go ahead and do that, run it through and test again, and you'll see that everything hopefully succeeds all the way down. All right, the last thing we need to do is add a deploy step. This is going to take our change set that we've created and actually make things happen in the physical world, the virtual physical world of AWS. So the way we do that is we go to our pipeline, we click Edit, and then we move down to the staging phase and click on the little pencil to edit that phase. And then we click on this little box to add an action. And the action that we're going to add, obviously, is a deploy category action. Give it a name, in this case, deploy change set, and then we're going to use CloudFormation to do it. What we're going to do is specify it under action mode. That's execute the change set that we created in the last step. So we just provide the names for the stack that we want to create or modify and the change set that we want to use to do so. And that's all we have to do. We run this, and everything will magically work. You can go ahead and test again however you like, and things will be built. All right, so we're making progress. We're about 2/3 of the way through. We have now successfully, with a few modifications, taken the same code base and deployed that using Code Pipeline. So CodeStar is kind of a cool new way of bringing together a bunch of Amazon tools into a single location. Think of it as an integrated single pane of glass view of Code Pipeline, CloudWatch, and GitHub, and a bunch of other things all in a single location. There's configurable tiles that you can move around. It's got a pretty cool wizard setup. Obviously, it's integrated with GitHub. It's a great way to get started with AWS Build Tools. If you're not familiar with AWS Build Tools, just build a CodeStar project and then look at all of the artifacts that it creates and how they relate together. And that in and of itself will give you a pretty decent idea of how things actually work. So we'll just do a quick walk around here of CodeStar. So it comes with an integrated wiki that you can edit, so you can sort of keep in touch with your extended team as they're accessing your project. It's also got direct integration with GitHub. So if I click on opening GitHub, I can look at the repository that underlays this particular CodeStar project and then switch back. I've also got whatever my deployment strategy through Code Pipeline is over there on the right. I can click on Code Pipeline, go directly there, see what's going on, make changes, or release changes from there if I want. We've got an integrated CloudWatch stack that's providing basic metrics around our Lambda function. And of course, we can also create issues inside of GitHub. So we'll go ahead and just create a random issue here. And those issues are going to be available and visible, and you can interact with them from inside of CodeStar. So again, it's just a great sort of single pane of glass view. And of course, any of these tiles are removable. You can move them around and set them up any way that you want. So how do we get started? So the first thing it's going to ask you is to create yet another service role, and you have no choice. You have to do this, or you can't use CodeStar. So go ahead and click Yes, Create Role. Then click on Create a New Project. And on the left-hand side are a bunch of filters that you can use to narrow down the choice of templates that you want to use. So in this case, we're going to run a web service using AWS Lambda running serverless. So we'll click that. We're going to give our project a name, and then we're going to integrate with GitHub by clicking on the giant GitHub icon. We're going to run through the same process of granting authorization, give our repository a name, and that's all there is to it. One thing, you do have to select the option that will allow CodeStar to modify AWS resources on your behalf. Again, if you don't do that, you can't use CodeStar. All right, off we go. So it's going to give you some useful information about getting to your repository, and then it will spend a few minutes building itself. And once it's done, you can sort of clear up the interface here by closing those things, and then we're ready to actually migrate. So one of the things that we have to do, if you want that integrated stack to work correctly, is change your Lambda function name in your configuration files to whatever your CodeStar project spit out. So we're going to go to Lambda. There's the function that CodeStar just created. We're going to copy the name. These are the other things you need to do. So clone your repository, your new repository, copy the code from your old repository into your new repo, change the name of the output file, and we'll see how to do these all in detail in a bit, in build spec, change the name of the function, push all that back up, delete the CodeStar generated stack, remove the parameters from the generate change set stage, and then add the ability for the CloudFormation worker role to pass itself to the GitHub Lambda admin role. So how do we do this? Changes to the template to buildspec.yaml. We just changed the output template file. This is what CodeStar generates by default, and it's easier to just do it this way than to go try and change the CloudFormation template. So we just change it to template-export.yaml. Moving on, we change the function name to whatever CodeStar spits out, and we're good to go. We've now reconfigured our code pipeline and CloudFormation template files to work. The next thing we need to do is edit our pipeline, go to our generate change set phase, and remove the parameters. All they are is a project ID, but they're not useful in our context, so we'll get rid of them. We delete the stack that CodeStar generated for us in the first place. And then the last thing that we do is go to IAM and add this particular capability to the role that CodeStar created to run CloudFormation. So after we do all of those things, we release the change, and it will magically work. So now we have our code migrated from a pure GitHub Jenkins environment to a code pipeline environment to a CodeStar environment. So when I was at the booth earlier today, a few people came up to me and asked, how do we do this? How do we work with GitHub and Lambda functions in the cloud? And hopefully, this has been a useful sort of introduction to 3 ways that you can do that fairly straightforwardly. Now, obviously, there are a million permutations on this, and I'm sure everyone has different questions and requirements. And we at GitHub are not just interested in talking to you, we're very interested in hearing from you about what you're doing, the challenges that you're facing, and what sorts of information you might find useful from us, so that the next time we meet, we might be able to help you with those challenges. And that's all I have for you. So thank you very much. I appreciate it.